Hello everyone, in this particular video I'm going to be explaining to you about the concept of a Hall effect sensor. Hall effect sensor is a sensor that it takes magnetic field that is around us. This magnetic field sensor has 4 pins. As you can see, it is available over here. The left corner is the one which is called as the analog pin, and the one on the right corner is the one which is called as the digital pin over here. And you have the power supply and the ground pins in between. So these sensors, I'm going to connect them to an Arduino board, which is the Arduino Uno over here. And the analog pin, the orange, you can see that the digital wire is the orange color wire, and that is connected to pin number 2, and that pin number 2 you can see it over here. Similarly, the analog pin, which is on the left extreme corner, on the top corner, which is the blue wire, which is connected to the pin number A0 over here. You can see that it is connected to pin A0 over here on this particular part. Similarly, the power supply and the ground pins are connected to the 5 volt and the ground. You can see that the yellow wire, which is the 5 volt, is connected to the 5 volt from my particular sensor to this particular field over here, and similarly the ground pin is also connected over there. Okay, so now coming into the programming part over here, you can see that this is the simpler program of representation of a particular Hall effect sensor. You can see that I'm declaring two variables over here. What are the two variables are? One variable Hall sensor, which is for detecting the analog signal from pin number A0. That is what you see over here from the particular pin A0. You can see that the blue color wire which I've connected. So I'm receiving a signal from there, and the other signal is Hall underscore sensor underscore D, which I am receiving from the pin number 2, which is digital pin number 2, as you can see over here, the orange color wire pointing over there. So I'm receiving the two signals over there from the Hall effect sensor, so I can receive an analog data and I can receive a digital data. So digital data, if it is 0 means there is no magnet over there, and if it is 1, you can understand that there is a magnetic field available over there. And when it comes to analog data, the magnetic field strength can be measured through that. So I'm initializing in both the values to 0. So my particular output values that I'm reading, I'm going to put it into a variable value 1, and I'm going to put it into a value 2 over here. So please remember, this is where I'm going to read the data, Hall sensor and Hall sensor D, and I'm going to put it into two variables, value 1 and value 2 over here. And I'm going to use my particular serial print begin, the serial print monitor, which is available over here. From the serial monitor, I'm going to read the data that is available. So I'll be using the concept of serial begin over here, and I'm using a baud rate of 9600. Similarly, my pin mode, as I told you, I am getting the input from the particular sensor, so it is an input that is being read over here. And similarly, what is to be repeated again and again is specified in the while loop over here. So in this while loop, as I told you, value 1 and value 2, the two variables, they are assigned for reading the Hall sensor and Hall sensor D value. Hall sensor, as I told you, is the analog value, and Hall sensor D is the digital value. So this sensor is taking data from the real world, so it is going to read the value, and it is going to be an analog signal. So I'm going to give analog read. The keyword is analog read over here. And similarly, I'm going to take the value from the digital pin. So the next data that I'm next is stored in value 2, which is going to be digital read. So digital input is stored in the form of digital read, and analog data is read and stored in the form of analog read signal over here. Where am I storing them? In value 1 and value 2. Now what is my next step? I need to I need to print these values in the serial monitor. So I'm going to use serial print for value 1, and I'm going to use serial print with some space for value 2. And every 2 seconds there's going to be a delay of 2 seconds over here, 2000 milliseconds. So every 2 seconds the value is going to be repeated in this particular loop over here. So as usual, when I have my program, I will first verify it and I will upload it. So I'm now uploading my particular program into this particular Arduino Uno board over here, and you remember the baud rate is 9600. So I go into the serial monitor, and what I do over here is, you can make sure that the baud rate is 9600, and you can see that initially all the digital values are zeros, and you have your particular analog value here. Due to a little bit of electromagnetic interference available in the atmosphere around you, you will be getting one values also then and there. But now we will verify what is happening when I keep it near a magnet. Okay, so I'm going to place my particular Hall effect sensor near this particular magnet over here. You can see the green light available on this corner over here. This particular light, when it comes near a magnet, you can see the particular light glowing, and after that when it goes away, you can see the light fading away. So this principle you can see over here, it is much clear. This is a magnet, and when it comes near the magnet, you can see the light is glowing over here, and when it comes farther away, the light goes off. Light is, when it comes closer, light is on, when it goes away, light is off. So the same thing is what is happening in the particular digital value over here also. When I bring it close over here, you can see that for this particular green value that is available here, the particular corresponding value becomes 1 over there. Now you can see the values are 1 over there when I'm keeping it near the particular sensor. I'm not moving it over here. You can see the value is 1 over here, and the LED is continuously glowing. So this is proving that the particular sensor is sensing magnetic field over there. Now you can see that if I move it away from the magnetic sensor, you can see that the value had become 0. So again, I can move it closer to the particular magnet over here. When I move it, you can see the green light growing as very bright over here, and you can see the value updated as 1. The values over here are updated every 2 seconds. So this particular sensor that you are using over here, you can use it for different kinds of applications. If a magnet is around you, you can keep a particular buzzer, and you can write a program accordingly that when a magnet is being detected, a buzzer alarm can go on. So this is what they used in they use in safety precautions and so on. And similarly, you can use it for finding the rotation speed of a wheel. So when you keep this particular a sensor on a wheel and you keep a magnet on the wheel, what will happen is, as the wheel keeps on rotating, how many times it is rotating per unit time, based on that you can put a calculation formula and you can find the speed of that particular RPM of that particular vehicle. So these are a few applications of this particular sensor over here. I hope you are able to understand this with the basic Arduino. Thank you.